So remember, for the equation, when you plug in, you have ln of x over x. So that's ln of e squared over e squared. And then Yoel asked a good question. Can the ln and the e cross out? Yes, but if you're not sure, you just leave it. Okay, but they do cross out just for practicing. So that's really just 2 over e squared. Hello. So your point is e squared 2 over e squared. Okay, then what else did we say we need? The slope, which is plugging into the derivative. So I want f prime of e squared. And notice they already gave you your f prime right here. So it'd be 1 minus ln e squared over e squared. And then again, remember, if you're not sure if the ln and the e's cross out, you just leave it alone. Leave it alone. Yes, ma'am. Yes. Thank you. Okay? So then my slope, now let's go ahead, since we know that they cancel out, let's do it. But remember, if you weren't sure, you leave it. What is 1 minus 2 across the top? Negative 1 over, and then e to the 4th. So then from there, you'd put it all together. It'd be y minus 2 over e squared, negative 1 over e to the 4th, x minus e squared. Now notice that tangent line is kind of ugly, but they already gave you the derivative, they gave you the equation, so you really didn't have that much to do. Okay, part B. Find the x coordinate of the critical point of f. Okay, we did this on your FRQ today. Do you remember what you had to write that they counted as a point? You have to set it equal to 0, which is totally annoying. Usually it's not worth a point, but on the test today it was. So first thing I would do is let f prime of x equal 0 or undefined. Now remember that on the one today, it wasn't a fraction. That's why you didn't have to set it equal to 0 or undefined. You could have just only picked 0. Okay, so look at the top. I'm going to let 1 minus ln x equal 0. Well, then I'm going to add my ln x across to the other side. Then I want to know when ln x equals 1. How do you solve that? Take e both sides. So it'd be e and e. E and ln cross out, then x is e to the 1, which is the same as e. Now, is there another critical number that will make this undefined? What will make the bottom of that 0? But look back at your question right here. What does it say about x? Has to be greater than 0, so this one actually doesn't count. Okay? Good. Okay, no.
Just 1 second.
Okay, look at part B. So then it says, okay, hurry up.
You're not ready for this action, Jordan.
I'm ready for it. Okay.
Synchronized.
Wow. That was very special. Okay, so I did the first part for you. After you find the critical point, what are you supposed to do next? Determine if it's a or neither. So you do that part. Now, question. Okay, guys, back here, live. Okay, when you set up your line chart to see what kind it is, what could you pick that would be bigger than e on the right side? Maybe e squared? What could you pick that's smaller than e so it comes out to be, don't do half e, do square root e. Okay, here's why. Watch. I guess I'll just help you with it. Okay. No, it doesn't. Look, watch. So, set up your number line. Now remember, it said that x is bigger than 0, so I'm going to start my graph at 0. I'm not going to put an arrow on that side. Then my only critical number is e. Okay, I'm going to show you with me plugging in square root e. Okay, we'll say that that's our test point. So if I plug that into f prime, remember f prime is here, it's 1 minus ln of square root e, which is e to the 1/2, over, and then square root e squared. Okay, here's why I might pick that. What happens when I do ln of e to the 1/2? It turns into a what? A 1/2. What's 1 minus a 1/2? 1 minus a 1/2 is a 1/2. And then on the bottom, if it was square root of e squared, that just comes out to be e overall, will it be positive or negative? Positive. Okay, now you do it with e squared. So it'll be 1 minus ln of e squared over e squared squared. And then your ln and your e cross out. But what happens on the top if you're doing 1 minus ln of e squared? It's 1 minus 2, which comes out to be a negative value. That's true. I guess we did in part B. But if it comes out to be negative, then what type of critical number is e? Max. Very good. Now make sure you want to label this stuff. Okay, so on top I would label this f of x. On bottom I would label this f prime of x. Now, if it says to justify, which it does, then remember you would have to state this is a relative maximum because f prime changes from plus to minus. What do you mean by punctuate?
Periods.
I mean, no. I guess you didn't have to put that. Okay, part C. Yes? Okay, part C says find the point of inflection. How do you find an inflection point? Take the what? Focus. Okay, the second derivative, right? So for part C, if I want a point of inflection, I need to find the second derivative. Okay, Grant, very fourth grade of you. Okay, so you need to take the derivative of this. What rule are you going to need? Quotient rule. So do it. Okay, remember it's ho d high minus high d ho over ho squared. Okay, do it. Also practice the labeling and stuff. Okay, also notice it says that there's only one point of inflection. So if you end up with two, that's a problem. Sean, do you want a cookie? I gave them all one before you got here.
Jordan, see, this is why I'm not good at FRQs. Look how unscrambled everything is.
So on the actual AP test, they break it up for you like these other ones. Where like you have a box for your work for part A. So maybe that will help you, I don't know.
No, when this box is different way.
Yeah, some people put the work in the wrong box though, and that did make it worse. Like,
Question about the box.
yeah, they weren't reading it well, I guess. I mean, you know, it's a good question, honestly. Okay, so if your high is 1 minus ln x, what's the derivative of that? Negative 1 over x. Good. Remember, ln derivative is 1 over x. Okay, then your ho is x squared. Then the d ho is 2x. And then remember that you don't have to simplify your work, but if you're having to find a point of inflection, there's a certain amount of simplifying you're going to have to do to be able to find that. So it's ho d high. So f double prime of x equals x squared negative 1 over x minus high d ho. So 1 minus ln x times 2x over ho squared. Now let's look for stuff that can reduce on the top. First thing that you should notice is that we have an x squared and a 1 over x. What can happen in here? Negative x, good. Okay, and then over here, I need to remember to distribute this minus. So it'll be a minus 1. And actually, let's multiply the 1 and the 2x as well. So it's minus 1 times 2x is minus 2x. Are we good with that? And then minus negative ln x is really a plus ln x, but then times a 2x behind it. X to the fourth. No, so you can't combine the 2x with the x because the x is inside the ln x, yeah? Okay, now, combine like terms on the top. What is a negative x minus 2 more x's? Negative 3x. And then plus ln x. And then over x to the fourth. Oh, and then there was a 2x back here. I'm going to put it right there. Okay, now, look at the top. What do you notice that the top has that could be factored out if there's a negative 3x plus 2x ln x, and x. So I'm going to take my x out here to the front. That's going to leave me with a negative 3 plus 2 ln x over x to the fourth.
Why does the X stay with
The ln,
Yeah.
because it's on the inside. That's like an e to the x. That x is inside natural log. That's why it can't go with anything else.
So what if it was natural log of another number, not X, but another number?
You still couldn't combine it with anything.
You couldn't take an X out, but could you still take an X out?
Not if it's on the inside. Think about there's like an imaginary parentheses around this.
I'm
That
saying
stuff is like inside a square root.
I'm saying if it was natural log of a number, could you factor out an X of the whole thing still?
If the x wasn't on the inside, then yes. But if it's on the inside, then no.
Okay.
Okay, now from here, look at your second derivative. What's going to make the bottom undefined? 0. What's going to make the top undefined? Two numbers. 0 or whatever the answer is to this. But can it be 0?
No.
No. What did it say at the beginning? X is always
Bigger.
greater than 0. So all that you need to do right now, I'm going to give you a second to do it, is set that part equal to 0. So if I'll do it on this sticky note since I wrote too big. Okay, negative 3 plus 2 ln x. What is that going to be when I set it equal to 0? Negative 3 plus 2 ln x. If I set that equal to 0, how would I solve it? Okay, 2 ln x of 3. Divide by 2. Ln x is 3 halves. Then e both sides. So x is e to the 3 halves. That's your point of inflection. But remember, really, you end up getting two answers, that and 0. But then 0 is eliminated because they said x has to be bigger than 0. Okay? That would be your point of inflection. Okay?
Ooh, I like the way you wrote the F of
Thanks.
pretty clean.
Thanks. Okay, last part, part D, says find the limit as x approaches 0 from the left.
From the right.
Or, sorry, from the right, thank you. So, look up at your graph. Okay, come up here to the top. Okay, here's my f of x. What is ln x doing as I approach 0 from the right side? Think about the graph of ln. It's going to, okay, here's a graph of e to the x, right? Here's a graph of ln x. It's headed to negative infinity. Okay, on the bottom, I just have a normal x. What is x doing as I head to 0? It's going to 0. So if I have infinity over 0, are you allowed to divide by 0? No. So you would put what? Undefined or dne. Okay? All right. Now, also a quick question here. Could you have done L'Hopital's rule on this? Answer is no. What are the conditions for L'Hopital's rule? The top and the bottom have to equal 0. So if you had ln x is going towards 0. Because think about it, as I trace the graph, what are my y values getting closer to? There does not exist because they're just going to infinity. That's right.
It's just normal.
Yeah. ln x is in normal. This is f of x. Yeah, so remember, this one is not 0 because it's going way past 0. It's going towards, this one is dne.
Why is X 0?
Because think about the graph of 0 is just a straight line. So if I trace towards 0, what's it approaching?
Oh, interesting.
0.
I
Yeah.
thought you meant just the line itself.
No, it's as your x is approaching 0. Okay, go ahead and turn the page. Okay, this is a good one. This is a good one. Okay, part A, you want an equation of a tangent line? Okay, we just did one of those. Yoel, what do we do first? Okay, point and a slope. X is 1. How do I find the y value?
Didn't we do
Plug it
this
into the original.
Or is it different?
This is a different one.
Plug into the OG.
Okay, OG equation. So f of 1 is e to the 2 times 1, which is just e to the 2. Okay, after I find the point, I need the slope. A slope is a derivative. So if f is e to the 2x, then what's f prime? e to the 2x times 2. Very good. Then we're plugging in 1. Make sure you're labeling stuff as you go. 2e to the 2 times 1 is 2e squared. Okay, so just kind of like that other one, your equation's coming out kind of messy, but the actual math part is not hard. So it'll be y minus e squared, 2e squared, x minus 1. Probably that would have been worth like 2 points on the AP test-ish. Okay? All right, go down to part B, set up your integral. So look at your graph that they gave you. They want you to find the area of region R. Okay, that's this area right here. If I want the area of that region R, set up your integral. You're doing it normal dx. Where will you start integrating from? What x value? 0, and you'll stop at where? At 1. Good. So 0 to 1, and then what's the top function? E to the 2x, and what's the bottom? 0. Good. Okay, now this one actually asks you to do it. Obviously the 0 you don't need, but what method would you need on that? U sub. So your u would be 2x, du is 2 dx, which means that dx is du over 2. Good. So then I'm going to rewrite my integral. It'd be e to the u minus 0 again. We're letting that go away. Dx is now a du, but then over 2, so I put a 1/2 in the front. What is the antiderivative of e to the u? E to the u again. And then you have two choices. You can go back to your old endpoints, or you can change them. I'm going to change them, but it's not wrong if you want to go back. So if this was a 2x, what is 1 plugged into 2x? 2. This is a 0. What is 0 plugged into 2x? Still 0. Then I plug in 2 and 0, and then I subtract. So if I plug in 2, I have a half e squared. Plug in 0, I have a half e to the 0. And then what do I do with those two values? Subtract. So you'd have a half e squared minus a half. And then remember, as you get closer to the AP test, I would really avoid boxing stuff. Just because if you box the wrong stuff, it messes it up. It's not like you'll be penalized as long as you do everything perfectly, but I would just not box. Also, are we good with why the e to the 0 fell off? Because it was 1. Okay. All right, go to the next one. Okay, part C, same question. Says we're going to revolve around x equals 3. Okay, this part is tricky, so I'm actually going to do it, I guess I can just do it right here. Okay, so remember our stuff? We said that y equals, this is e to the 2x. Redraw it because we're going to have to change some stuff. And then this is x equals, what was it? 1? Yeah. So this point is 1 comma
It's a vertical line.
e squared. Yes. Okay, no, well, it's not because it's a vertical line. This is why. What you're revolving around is vertical.
Yes.
So it doesn't matter that there's a vertical line in it. It's the fact that you're going around a vertical axis. Is that what you meant?
Yeah.
Okay, good.
Those three over one.
Perfect. Okay, so first thing I want you to do is solve this for x equals. So if I wanted to solve that for x equals, what would we have to do? Okay. Yep, so you'll do ln y equals, that'll give us a 2x, then x will equal 1/2 ln y. Okay, good. So far so good. We have x equals half ln y, and then we have x equals 1. That one's already ready to go. Okay, what else are we going to need to use on our integral? And what's our y value going to be this time? E squared, right? Okay, now we have not done one of these in class except for one time after school if you came to this session. Okay, when you revolve around, what are we going around? X equals 3. Okay, so x equals 3 would be over here. I want you to think about if you have the same outer R and inner R the whole time. Okay, what is my inner R from where to where? Where's little r? from 1 till 3, right? This is little r. Oops, that's not a little r. Okay, here's the problem. For your capital R, it switches. When I'm below this line, I'm going to draw in a little dotted line here. What is my capital R? From 0 to 3. But then for my R above that line, what is it? Half ln y to 3. So we are going to have to split this up into two parts. Now look back at your graph. What is this point right here? Is it labeled for you?
1.
Okay, and now think about it. If it wasn't labeled, what's e to the 0? 1. So you already know that it's 1, but this point right here, I'm going to have to actually break my revolving region up into two separate integrals. So let's do below my hand first. So where am I integrating from? What are my y values? 0 to 1. And then I need to do big R squared minus little r squared. What did we say big R is? Right minus left. 3 minus 0, so that's 3 squared. Minus little r squared, which is 3 minus 1, which is 2 squared. Plus. Now, what have I already forgotten that I need to fix? Pi.
Oh,
Yeah?
volume.
Because it's rotating, it's revolving. Okay, now I'm going to go above my hand this time. So where am I starting my integral? 1 until e squared, right?
Oh, yeah.
Because I have to use my y values. And then what is my capital R above the dotted line? Minus 3. Now, the order you put it in doesn't matter. I'm going to do the 3 first just because I want to stick with right minus left. But if you had done it backwards, remember you're squaring, so it doesn't matter. Okay? And then minus, and then your little r is still 3 minus 1, which is 2 squared dy.
Wait, what do you mean it doesn't matter?
So if you wrote this in here backwards, think about if I square 5 minus 2, right? That's 3 squared, it's 9. What about if I do 2 minus 5? Well, it's negative 3, but when I square it, it's still 9. So that's why, that's the only case where it fixes itself is if it's inside a squared and you did it backwards. Okay? Now notice it says do not evaluate, thankfully. But it is possible, they've only done this on the AP test twice in like all the 8,000,000 years they've given it. Okay? Alright, go to part C. Part C says our region is going to be squares, perpendicular to what?
1.
So that means that it's going to be dy. And then it says set up an expression involving one or more integrals. The hint there is you're going to need more than one integral. So looking at my region, I'm going to draw it in here. Okay, this is x equals a half ln y. This is x equals 1. Do I have the same base all the way across my region? Well, last time we were rotating. Now we're doing cross sections. Well, it's kind of similar, but not exactly the same. And take out the pi, and you're not squaring them separately anymore. Okay, so look, I'm going to draw in my dotted line again. From below the dotted line, remember that when you're doing a cross section, your base can't leave that region. So what is my base for below the line, right minus left? 1 minus 0. What is my base for above the dotted line? 1 minus a half ln y. So you have different bases depending on whether you're above the line or below the line. Now, as Grant said, when you're doing a square, there's no more pi in your formula. But the other thing that changes is that your 3 is gone. These are your different bases. So my volume will be 0 to 1, I'm on the bottom half. And then our base is 1 minus 0 squared dy plus, and then for my second part I'm going from 1 to e squared. That's my second set of y values. And then my base for that part was 1 minus a half ln y squared. Okay, and then something else I want to point out to you is that look at the way that you're squaring here versus the way that you're squaring here. Do you see how these are squared separately and subtracted? These are subtracted and squared together. So there is a difference in the way that you're writing it, and when we start correcting those tests, some of y'all had that backwards. When they're separate R's, you're squaring them and then subtracting. Versus here, you're subtracting and then squaring as a group. Okay? All right. Good job. Turn the page. Yep. Okay. Next one. Okay, look at it. Okay, in the chart, Ruth rode her bicycle on a straight trail. She recorded her velocity in miles per hour. First selects values, blah, 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 as shown above. Part A, use the data in the table to approximate her acceleration. If this is velocity and you want acceleration, that's the derivative, but what type? A real derivative or an average? Good. So if this is velocity and I want acceleration, I'm going to have to do an average rate of change. Because remember, they didn't give me the real equation, they're just giving me a bunch of values in a table. So I'm going to put A of 1.4 is approximated by. They would not count off points if you put in equals instead. And then what interval am I going to do an average rate of change on if I want it at 1.4? Good. You'd have to go here because that's going to put 1.4 in the middle. So I'll do V of 1.6 minus V of 1.2 over 1.6 minus 1.2. Okay, and then as you guys saw in your mock exam today, they do give a point for that. So if you refuse to set it up and just show your work, you're going to miss that. Okay, 1.2 and 1.6, what are my y values? Yep, 16.3 minus 17.2. And then on the bottom, 1.6 minus 1.2, I'm just going to put 0.4. Okay, then on the top, those were velocities. So what was velocity measured in? Miles per hour. Then the derivative of that is going to be miles per hour squared. Because you're doing miles per hour divided by hours, that's where the squared comes from. Okay? Then notice here it said indicate units of measure. Almost any time that they put that, that means they're giving a point for that. Okay? All right, part B. Using correct units, interpret the meaning of the integral from 0 to 24 of v of t. This is one of the ones that you should know. When you integrate velocity, what do you get? Okay, not total distance, because remember, distance is if there's bars. Okay, yeah, okay. Make it displacement, do y'all remember?
Oh, yeah.
Okay, what's the difference? If it's like this,
It doesn't have absolute value.
it's displacement. And if it's like this, that's distance traveled. Okay, so you have to remember that if they didn't put bars around it, even though you want to say distance, you have to say displacement. Because a normal integral can be negative, just like displacement can be negative. Okay, so let's interpret the meaning. We would say the integral from 0 to 2.4, v of t dt, represents, now they said using correct units. So if Ruth is on her bicycle doing miles per hour, what are her units going to be when you integrate it? The number of miles of displacement, because we don't want to say distance.
You say distance, how much do you get points taken off?
It just depends. Some years they've taken off for it, sometimes they've been kind of easy and let you have the point. Okay, miles of displacement that Ruth traveled over what time period? Okay, so over 0 to 2.4, and that would be measured in what? Hours, because it's time.
Oh, time.
Okay, so I already put the number of miles here. But you would have to put both. Units on your displacement, she's traveling in miles, and then units on your time, we're counting hours. Okay? Then it says use a midpoint Riemann sum. This one, is it going to be the short version or the long version? Okay, good, short. So 0 to 0.8, 0.8 to 1.6, 1.6 to 0.24. Why are we skipping one? Because it's a midpoint. Very good. So I'm going to use this guy, and this guy. What is my delta x if I skip one and it was originally going by 0.4s? So it'd be 0.8. So I'll do 0.8 bracket, and then I'm adding the ones that I listed. So that one, and that one. Okay. All right, part C. Oh, and then what would that have been measured in?
Miles.
Good. Okay, so she went 1,000,000 miles. Okay, part C. For 0 to 2.4 hours, Ruth's velocity is given by blah, blah, blah. According to the model, what was her average velocity? Now, this is already her velocity. You want her average velocity. Which average is it?
Average value.
Yes. Okay, because remember, if it was the average rate of change, it would have been average acceleration you'd be looking for. So because this is velocity and this is velocity, it's average value. What's the formula?
1 over
Okay, so 2.4 minus 0, integral 0 to 2.4. And then it would have been your function. You can either write g of t, or you can write the whole thing out. Now, this one you would have had a calculator for, which we're not going to type it in. Hopefully you know how to do that. If you don't, I don't know, you've been dead for a while. Okay, part D. According to the model, is Ruth's speed increasing or decreasing at time 1.3? What would you need to plug into to know if her speed is increasing or decreasing? Good. So now keep in mind, I don't have acceleration. Good job. Look, I'll put it up here for you. Okay, so alpha 24x plus 5 sine 6x x plus 0.7. Okay, so look, watch. What are the two things I need to find in my calculator? You don't have to do it yourself. You can just watch. First thing I need is what? You need the y value. And then what else do you need besides the velocity we said? Acceleration, which would be what in my calculator? The derivative. So you do math 8, d dx, y1 at 1.3. Okay, now looking at her velocity and her acceleration, is she speeding up or slowing down?
Speeding up.
Speeding up. Now, one other place you could have looked for this, guys, look here. Okay, at your graph. Okay, obviously I'm going to need to zoom out here. Hang on. So my values are in the 20s. So we need to make our window a little bit bigger. So let's go to 13 and we'll just go 0 to 5. Okay, look at your graph. Okay, this is a graph of velocity. Does it make sense that it's speeding up if I'm above and I have a positive slope at 1? Okay, are you listening back there? Yes. Okay. Okay, so look, if I find my slope at 1.3, okay, look at it, it's a positive slope and it's also above. So that's another way that you can tell from your graph that it's speeding up. It's because your values are above, that's positive velocity, and your slope's positive, that's acceleration. Okay? So let's write it out. So you would put her velocity at 1.3. We already typed it in right here. Came out to be 18.0963. Her acceleration at 1.3 was v prime of 1.3. We also did that in the calculator. We got 3.7611. 3.7611. And so based on those two values coming out to be positive, we can conclude her speed's doing what? Good. So speed is increasing at t equals 1.3 because v of 1.3 and a of 1.3 are both positive. Okay, if they had both come out to be negative, remember that would also count as speed increasing. They just have to match each other. Okay? I guess we can finish 2 minutes early. Good job. Give me your sheet. Today was FRQ number 2. Make sure you put the right number. For whatever reason, I accidentally numbered your calendar stupidly, but we're going to stick with it.
Miss Jane?
I lost my sheet. Is that cool?
No, that's not cool.
As long as you still have all your packets, which I'm sure you do
Wow, I got 92.
so far. Good job. Ah, sorry.
What if I don't remember these and I forgot to write them down?
You can look up on the attendance what days you came in, I'll tell you.
Yeah.
Look on there and see and I'll tell you.
Oh, I also marked one of those days wrong. I remember that.
Or do you still have your packets? Probably not.
I think I do. I just don't know where they are.
Okay, if you tell me what days.